Hello friends, how are you all? Hope you all are doing good. So today we are going to discuss and practice how to give IUPAC names to the organic compounds. And if you see all my videos on this topic, you would be able to give IUPAC names to all these compounds. Alright, so let's get started. So children, this is an organic compound. Its IUPAC name is methyl butanol. The IUPAC name has many segments, we can say, word root, prefixes, suffixes. Word root indicates the number of carbon atoms present in the longest possible chain. So here, this is one chain having 3 carbon atoms and this is the chain which have 4 carbon atoms. So we'll take this chain as a parent chain and it has 4 carbon atoms. Therefore, the word root is written here as but. So depending upon the number of carbon atoms, we can write the word root as shown here in this chart. So for only 1 carbon atom, we write the word root meth. For 2 carbon atoms, eth, 3 prop, 4 but, 5 pant, 6 carbon atoms, hex, 7, it's hept, 8 oct, 9 non, 10 dec, and so on. And the type of bonds which are present in the carbon chain is written as suffix just after the word root. And you can see here, different groups are also attached to the parent chain, like this CH3 group and the OH group. So some groups like alcohol, aldehyde, ketones, carboxylic acids, etc., they are also written as suffix, whereas some groups, they are written as prefix. So let's find out which groups are written as prefixes. So if halogens are attached to the carbon chain, they are written as a prefix halo. What are halogens? Fluorine, chlorine, bromine, iodine. So if fluorine is there, then we'll write the prefix fluoro for chlorine, chloro, bromine, bromo, and for iodine, iod. And also if alkyl groups are attached to the carbon chain, they are also written as a prefix. So what are alkyl groups? These alkyl groups, they have one hydrogen less than their respective alkenes. Okay. Instead of ene, YL is written. Now let's give IUPAC name to these simple compounds first. So first we'll write the word root. So that indicates the number of carbon atoms in a carbon chain. So how many carbon atoms are here? 4. So the word root would be but. And the type of bonds present here in the carbon chain are all single bonds. So the suffix would be written as ane. So the IUPAC name of this compound is butane. Right? Now can you do this? The number of carbon atoms here are 6. So here you can see the word root is hex. And the type of bonds, they are all single bonds. So we write the suffix ane. So the name of this compound is hexane. Now this compound has a double bond. That means it is alkene, right? But first, here also we'll write the word root indicating the number of carbon atoms present in a carbon chain. So here, how many carbon atoms are here? 5. So the word root is pant. And since it is alkene, so the suffix would be given as ene. So we'll write ene as a suffix after word root, and the name of this compound is pantene. Now this compound has triple bond. That means this is alkyne. How many number of carbon atoms are here? 2. So for 2, we write the word root eth. And since it is alkyne, so we give the suffix for the triple bond as YNE. Now children, let's take this example. So the first step is to select the longest possible chain of a carbon. So we can select this chain, the straight chain, and we'll count the carbon atoms in it. There are how many carbon atoms? 7 carbon atoms are here. We can select this chain also. The carbon atom should be in continuation, that's it. So this chain contains only 6 carbon atoms. The straight chain contains 7 carbon atoms. We can select this chain also, but this contains only 5 carbon atoms. All right. Now, if I select this chain, right, this chain can also be selected. And how many carbon atoms now in this chain? It has 8 carbon atoms. So this is the longest possible chain we can select, right, as a parent chain. So children, this is the main chain. Now identify the groups which are attached to this main chain. Yeah, they are CH3 group and CH2 CH3 group. Can you tell me the names of these groups? So this CH3 group is, that's right, it is methyl group. And this CH2CH3 carbon chain, which is also called as a side chain, it has total of 2 carbon and 5 hydrogen. That means 1 hydrogen less than ethane. So this is ethyl group. All right. So now the next step would be to allocate the number to these locants so that they get the lowest possible number. So how can we do this? So we'll start numbering of the carbon atoms present in the parent chain. So I can number it from left to right also, like this. So in that case, this carbon is getting number 5, on which the locants are present. So these are getting, both are present on the same carbon atom, so they are getting the number 5. Now I can number it from right to left also. If we number this carbon chain from right to left, then the locants are getting the lower number 4 on the 4th carbon atom, methyl group, and the ethyl group are present. So this numbering would be preferred instead of this numbering. Now the next step is to write these locants in the alphabetic order. So for that, we see the first alphabet, E and M. So E comes before, so then ethyl would be written first, followed by methyl. So let's give the IUPAC name now. 4th carbon ethyl group is present. So 4 hyphen ethyl, then hyphen 4 methyl. Now these are the prefixes. After that comes the word root. And what is it? 8 carbon atoms, that is oct, and only the single bonds are there, then ane. So this becomes the IUPAC name of this compound. Okay. Let's take this example. Now first step is to select the longest possible chain. So the straight chain contains 6 carbons, and we can select this chain also, which also contains 6 carbons. Then we count the number of substituents or the locants in both the carbon chain. So in this chain, we have 1 chlorine and 2 methyl group. And in the straight chain also, we have 1 chlorine attached to it and 2 methyl groups are attached to it. So this is one and the same thing. Either you select this chain or this chain. All right. So let's select this chain. So you can see here 2 CH3 groups. That means 2 methyl groups and 1 chlorine atom is attached to the parent chain. 2 methyl groups, we can write it as dimethyl. Di means 2. So we can write it as dimethyl. And for chlorine, we write the prefix chloro. What is the next step? To assign the number in a lowest possible way. So we can number it from left to right also and from right to left also. So if we number it from left to right, the locants will get the number 2, 3 and 5. Okay. And if we assign the number from right to left, then the locants are present at number 2, 4 and 5 position. So we'll write here 2, 4 and 5. So here, which numbering will give the preference? So for that, what we'll do, we'll sum up these numbers. All right. So 5 plus 3 plus 2, this is 10 and this is 11. So the lower number would be given preference, and this rule is called as lowest sum rule. So when there is a confusion which numbering is to be selected, then we apply the lowest sum rule. At number 2 and 3, methyl groups are there. So we'll write here 2, 3 and hyphen. At 2 and 3 carbon atom, methyl groups are present. And at number 5, chloro group is present. And then write them in the alphabetic order. So which comes first? Here in this case, di, tri, tetra would be avoided because they are not the locants basically, right? They are not the groups. They are just telling the number of the groups present on the main chain. So here we'll see alphabetically between C and M, whichever comes first will be written first. So here we'll write chloro, which is attached on the 5th carbon atom. So this is 5-chloro. Then 2, 3, 2 and 3. So 2, 3, dimethyl. Then what is the word root? That's right, hex and A. So this is the IUPAC name of this compound. I hope it's clear to you all, children. That's good. Let's try to give the IUPAC name to this compound. So this is the longest possible chain of 8 carbon atoms. We can select this chain also like this. It contains only 7 carbon atoms. If we select this carbon chain, it contains 6 carbon atoms. So this is the longest possible chain, and we are considering it as a parent chain. 2 locants are here. So the next step is to number the carbon atoms present in the parent chain. So if we move from, say, right to left, so the locants are present at carbon number 4 and 5. Okay. And if we move from left to right, the locants are again present at number 4 and 5. Now, which will get the preference? If we apply the lowest sum rule also, then the number is the same. What are the substituents which are present on the parent chain? This is methyl group and this is another group. How many carbon atoms are present in this chain? 3. So it could be propyl group, but this is not, this is methyl group. We'll write here first. Now this is not a linear chain of 3 carbon atoms. If this carbon would have attached to this carbon atom, then this would be the linear chain, right? And this would be a propyl group, normal propyl group. But here what is happening, this carbon which is attached to the main carbon chain is attached to 2 carbon atoms, 2 methyl groups. So you see something like this. So then this is called as isopropyl group, the branched chain, right, of 3 carbon atoms. So this is isopropyl group. Now writing them in alphabetical order. So the I comes before M. So isopropyl group would be written first. All right. And then the methyl group would be written. If we go from left to right, then isopropyl is getting the number 4 and the methyl group is getting the number 5. And if we move from right to left, in that case, isopropyl would be written first only in the alphabetical order, but now it will get the number 5 and the methyl will get the number 4. So in this case, the group which is written first should get the lower number. So here isopropyl group is getting the lower number. So this numbering would be preferred. That means this numbering from left to right would be preferred. So here we'll complete this IUPAC name. How many carbon atoms? 8. So oct, only single bonds, ane. So this is the name which would be preferred against this name. Okay, children, now you can pause the video and try it yourself. Okay, so if we select the straight chain, it contains 7 carbon atoms. And if we select this chain, then also it contains 7 carbon atoms. So which chain will get the preference? In that case, we'll count the number of locands present in each chain. So in this chain, we see that we have 2 locands. And if we select the straight chain, we have 3 locands in it. So the chain having maximum number or the more number of locands, that would be preferred. So we'll select the straight chain as a parent chain here. All right. Now the next step would be to assign the number to the locands. So on moving from left to right, what are the substituents here? First write it. We have got chloro group, then methyl group, and a propyl group. Normal chain of 3 carbon atoms having 1 hydrogen less than propane. So this is propyl group. So on moving from left to right, the locands are getting the number 2, 4, and 5. And on moving from right to left, the locands will get the number 3, 4, and 6. So which will be given the preference? Apply the lowest sum rule. Here the sum is 11 and in this case it is coming out to be 13. So this numbering would be given the preference. All right. Now assign at number 2, chloro group is there. Methyl group is present at carbon number 5 and propyl group is present at carbon number 4. Blue numbering will prefer. Now write them in the alphabetic order and we'll get the IUPAC name. So first we'll write chloro. So it will be 2 chloro. Then methyl group would be written methyl and 4 propyl. Seven carbon atoms, hept, and all the single bonds are there, then ane. So this is the IUPAC name for this compound. So children, try to give IUPAC name to this compound by yourself and you can write the name in your comment box. So that's all for today. If you liked it, do hit the like button and share with your friends, especially those who are going to appear for 10th board this year, right? And in the coming videos, we are going to practice the organic compounds having double bond, triple bond, functional groups, alicyclic compounds, etc. Till then, bye-bye. Take care.